Hey, good morning, folks. Myself Anish and Uma, we are from Mavenir. Mavenir is not probably a very familiar name. So, we are a mobile telecom infrastructure company. So, to put it in more simple words, it's like the mobile base station tower and the entire network behind that. So, that's what Mavenir is, end-to-end network in the mobile infrastructure area. So, this to just to put some of the definitions clear. So, basically we are we work a lot on the cloud networking paradigms. So, when we are talking about cloud routing, it is about the networking and forwarding requirements within a cloud, which includes data centers and those things. So, what we are trying to present here is the virtual cloud routing environment that so when this entire cloud routing and the networking is done in a virtual realm, that is in the based on the software forwarder, that is where the virtual cloud router environment is really coming into picture. So, last year we were here to present the first one in this, that is the virtual cell site router. Going forward, we found this getting applied in and expanded into much wider areas that we are seeing around. So, within the mobile network itself, we are trying to have SONiC based networking in the media gateway, UPF, and in the aggregation router scenarios, where sometimes we are even talking about having dedicated card server for the networking requirements. This is and also there are some servers that are actually getting dedicated for the control plane routing for the various control plane applications in the mobile network. So, that is another area that we are seeing the virtual cloud routing environment getting expanded into. This is in addition to most of the things that that are very obvious to us, like the enterprise connectivity requirements and the network simulation and testing, that is the backend customer labs that we have. Over and above the load balancers and the broadband aggregations. So, so the basic nature of all of this that we are trying to address is the first access router, that is the from an application that is running, the router or the networking device that first processes the packet. So, the application space of the networking application space that we are talking about primarily is that of an access router. Yeah. So, the typical feature set that would be of interest is one thing primarily will be in the security front. So, the firewall security gateway and the IPS, IDS, the intrusion prevention detection and those systems. And most of the applications today, a whole lot of applications today are getting time sensitive. So, many of them are actually requiring a efficient source for the precision time. Then there are use cases for various gateways in these systems, for primarily as an ISP gateway or a secure gateway or a VPN gateway. QoS is mostly applied on these access devices. So, and going forward, we can, this is not an exhaustive list, but this is just an indicative list of what is really different when we in the space that we are talking about the applicability of SONiC when we are talking in the virtual cloud routing area. So, what it makes to make this virtual cloud routing? So, there are a bunch of requirements that is basically a collection of what we saw in that to make out what requirements are applicable to that particular scenario, and then the interfaces. So, the The interfaces typically includes the various ways of integrating the various interfaces that we have, that's the network interfaces and the all the other interfaces, the management interface, the control plane interface, and all those things come under this. And then the instance management. Typically these are spawned, resized and purged on a dynamic fashion based on moving workloads or on an on-demand basis. So what is this virtual cloud routing environment comprises of? So primarily there is a platform which primarily gives the environment where the containers or the VMs run, the orchestration happens, and then comes the hardware, which is the hardware requirements for running this, which includes how the NICs are getting provisioned, the compute and the storage and the memory needs to be provisioned for these cloud routing instances to run. The other things are pretty much what we all know about and adding to that, we have some stricter, more exotic telemetry and management things, because almost certainly these are not the devices that get physically managed or a CLI based management, or we can't really expect somebody to go and do a config interface address kind of management. All of them would typically get automated. So what does SONiC provide for the virtual cloud routing environment? So it provides the management interfaces that is today we get a REST API and CLI based interfaces. So we are trying to bring in a netconf based interface as well. So adding to that, it provides a fairly large extensive middleware, which includes the which starts from the various Redis DBs that is there down till the syncd, the device management and integration with the routing stack. The data model is what we really think is a fairly strong point here, because though practically everybody ends up writing their own data model, maybe for their own reasons, but still this open data model really helps in integration. The community support goes beyond saying that we have a community support available. This is in addition to some of the vendors like Dell, who are actually providing fairly good support for the people who are coming up on this. The critical features, most of them are very obvious to us. So some of the things that are of higher importance here are like the QoS requirements become fairly stringent when it is when the resources are crunched. Many times we see this in working in constrained resource environment, and the unequal cost multipath and the policy based routing becomes important here. So the lawful intercept is another area that becomes really important, because typically many of these things may not be of too much importance in a data center forwarding environment, but when we are applying this to a virtual cloud routing environment, we are kind of finding requirements, and we are trying to implement many of these things. Yeah. So Uma will be talking about some of an example based applicability of the cloud routing.
Okay, so let's take Mavenir virtual cell site router, which we call as VCSR, as an example for virtual cloud router. So when we make a call with our mobile, So traffic, the radio traffic will go to a RU, so that is a radio unit, and that passes the traffic to a distributed unit, and distributed unit handles all the MAC and the physical layer function, and next comes the cell site router. So the cell site router's primary function is to provide connectivity to all these DUs, and it will route the traffic through the mid hall to a control plane, centralized unit which actually handles the control plane function, mainly signaling and connection. So the packet core takes care of the data plane function, and that is mainly routing and management. So if you see the RU, DU and the cell site router, you can find at the bottom of a cell tower, and the CU is usually present at the edge data center. Now in Mavenir, since it's Open RAN cloud solution company, all these nodes are in the cloud. So Anish already spoke about number of use cases for virtual cloud router. So VCSR is a specific use case for 5G. So it comes with its own constraints. So since it runs in a cell site, so it has to run with minimal memory and minimal CPUs. So moreover, the features, the most important features would be cost and security. And Mavenir VCSR runs with just 2 P cores and 2 GB RAM. So we have the VCSR come up as a pod, and it has the control plane which runs on SONiC, and data plane which runs on FDIO VPP. Now this runs along with other pods and other applications, including the DU which is co-located, and all of them run on a blade server or a COT server, typically say a Dell server, right? And all of this can be orchestrated using Kubernetes. So if we have to develop our own virtual cloud router, we need a data plane. So we have a lot of choices. So a data plane that should do very high speed packet processing. So one choice is FDIO VPP, which Mavenir as well uses, right? So FDIO VPP primarily because VPP helps with vector packet processing, and it uses DPDK, wherein it bypasses the kernel altogether, and that improves performance by a great deal. So you can also go with XDP with eBPF, where in the kernel with eBPF you can add some custom code in the kernel, and XDP can hook on it, and it comes very early in the packet path. So that as well helps with improves its performance. And then we could offload it to the NIC. So some popular ones are DPUs. So you can, with DPUs you can get the entire processor and its ecosystem completely, all of them within a SoC. So there are many of them. So there's Marvel, Octeon, then there is Broadcom Stingray, there's Intel IPUs, and NVIDIA's Bluefield. So there are lots and lots of them. With AI coming to picture, there's also accelerators with this graphical processor unit as well. So what are the features we should look? One is multi-level encode and decode. As simple as you could have VLAN over GRE or VLAN over IPsec, and we should also have service chaining, wherein we should be able to provide chain the services for any particular packet. So we could provide load balancing or intrusion detection, prevention. All these can be easily chained. We should have the flexibility to chain it. Moreover, we should be able to develop features easily. It should just be a plugin when we add it, and it should work. So, in order to match or at least come closer to the hardware based solutions, we have to do some optimization. So, DPDK we already spoke about. So, VPP comes with DPDK. So, that improves performance 10 folds compared to what kernel routing can do. Then SRIOV, single route IO virtualization. So, here there are so every PF that is in the NIC card will come with multiple VFs. So, each of these VFs can be owned by a VM. So, when packets come to the VF, it will directly be given to the VM. So, this bypasses the hypervisor altogether, and that improves performance again. Then we can do CPU pinning. We have done CPU pinning in sense. This is more like CPU affinity. You make sure your application runs on a particular CPU. And even with this, you cannot stop the kernel from running its housekeeping processes on your particular CPU core. So, we have CPU isolation. So, there's so many optimizations that can be done. This is just what we have done and experienced with this. The list is actually exhaustive. So what is the ideal feature set? Most of it, ideal feature set of a distributed control plane, most of them here are offered by SONiC. It was also good to have service chaining and path computation. And there are a lot of open source models. SONiC comes with FRR, there's also BIRD, and there are vendor based solutions like Juniper CRPD, and there are solutions by IP Infusion as well. When it comes to management, yeah, we all know this. So, SONiC provides all these features. So, specifically wanted to speak about the commercial support for network management or controllers. So, mainly it should be able to give us automation, orchestration, and monitoring of the network. So, there are 2 of them. In fact, there's 3 of them. There's also, so there is Dorado, there is Beyond Edge, and there is Aviz one solution. So, that is those that use SONiC. And recently we did a POC with Dorado. So, we were able to integrate with their Dorado cruise controller. So, we were able to do it a little faster thanks to open data models. So, finally, why VCR or why virtual cloud router? First of all, containerization. So, with containers, we say you can build once and run anywhere. And moreover, it's lightweight, and you can deploy on demand when you need it. When you want to scale, you can just deploy it. And it can be orchestrated, wherein you can easily scale up or scale down. With now, we are going away with a dedicated hardware. We have power savings, we can reduce cables, and we also free up some rack space which we can use for other purposes. And this brings in the total cost for us. So, by design it is programmable and elastic, wherein you can just throw as many CPUs, or you can throw more memory and you can make the performance better, or you can scale up. Lastly, AI services, the popular topic here. So, we can say AI and cloud actually are symbiotic. They have a symbiotic relationship, wherein AI can use cloud's infrastructure, and the cloud can make use of AI services for intelligent deployment and automation. Also, we can, we can provide many, there are many benefits. We can have, it can, so for example, you can detect a 0-day attack much prior, and we can also, if there is some rogue traffic, we can apply some service policies automatically, and it helps in global optimization. So, that's all from us. Thank you.
for the presentation. Is there any question? Yeah.
Hello. Yeah. In your slide, actually, you mentioned about IPsec. So, what is the application of IPsec in this telco?
Very simple example is that from a there is a base station tower. The connectivity from the base station tower to the central office, it could be on any line, a lease line. You could another very common thing that we see is the this microwave transmission is happening. All these require higher safety. So beyond the for the control plane safety and for the safety that are not just native for the UE transmissions, we need an IPsec. So even the UE traffic, we are the user equipment traffic, we are sending it over the IPsec.
So it means we are sending like signaling or control plane traffic from base station to maybe the nearest backhaul or the core. That's what you are talking about.
That and even the mobile traffic.
Great. Okay. Thank you.
So, yeah.
Good presentation. Did you have to bring any specific feature in SONiC for your cloud router solution?
In many things we had to bring in newly. So one major thing that we had to work on was on the QoS front. Because I said we are working on tighter constrained resources, unlike in a data center fabric. So the every bit and those things count, and sometimes the thing is that we have a fat pipe that is the optical link, and when the optical link goes down, the backup is the microwave link. So now the microwave link is significantly lesser bandwidth, so we do some kind of the unequal cost multipath and traffic split, the policy based routing, all those things come into picture. The other thing is that when it comes to the mobile traffic switching, you can very often find that it's a more fine grained forwarding that happens. So the many times the forwarding rules are more like flow based rules, and those things come into picture. So flow based, so the marking the flows and there is a GTP encap that happens. So which is a per UE traffic that gets marked. So and in addition to that, the network slicing and all those things are coming into picture. So the per flow based traffic is there, and the policy based forwarding is there. The access router typically comes with a whole lot of more requirements. So the ACL on the wire, because SONiC ACL was more for the control plane protection and not for the on the wire protection, on the wire traffic transmission traffic protection. So many features are there. We just didn't make an exhaustive list on that. So.
Got it.
So even we even had a protection feature for the control plane, because it's a first step. You could imagine the equipments are located on the base of a mobile station tower. Very often I could go and open up a thing and see what is there under a base station in a center in Bangalore. No safety. Somebody can come in, put in an Ethernet cable, and can get access to the very core of the network.
Got it.
So
and then following that, are you also looking at GNSS modules or any timing synchronization capabilities on those router solutions?
Yeah, PTP we run PTP, and so there are multiple components within the. So when we are talking about this cloud router, there are multiple components within that requires the precision timing. So we have a method of getting timing from one source, that is the GPS source in one of them, and distributing the timing to multiple containers out there, primarily through the SR-UAV interfaces.
Is that Linux PTP, or are you using a third-party PTP stack?
I'm not sure about it because the PTP was implemented by another team. So you have any idea about?
Distributed unit was what has the PTP.
Yeah,
So
we are not
so
sure
we
about
don't-
who is implementing on that. We only thing we know is that it runs on a different container and we provide the networking for that. Other thing is that sometimes even if there is a GPS signal cut for some reason, there is alternate GNS timings that are coming in. So so some base stations may not have this GPS connectivity. So all this networking we provide.
Got it. Thank you.
Hello, myself Partha from Broadcom. So I have a similar question to the IPsec. So you mentioned there is a lawful intercept that you are doing to trap the traffic, and we are actually trying to implement IDS or IPS. So my question is, to what level we are tapping? Is it the IPsec header only we are talking about, or you are going much deeper after the the IPsec has been the data has been really taken out from the IPsec packets?
This typically happen in the UPF node in the mobile packet core. So UPF is the user plane function. So there the GTP termination might happen or may not happen because it depends on the UPF chaining that is out there. So basically the UE traffic will be there. So one of the lawful intercept rule was about the that we have seen was about detecting and handling the telegram traffic differently. And yeah, did I answer your question?
Yeah, yeah. Thank you. Thanks for the nice, insightful presentation. Thank you.
Thank you.
Cool. Thanks a lot for presenting.
Thank you.
So we will take a short break here for lunch. Lunch is ready, and we'll take like 45-50 minute break, and after that we will start by almost 1:30 with AV's network. Thanks a lot everyone. Enjoy lunch.